bonds, chemical bonds that is. We're going to talk about chemical bonds, and we've got to talk about electrons. So before we talk about the specific types of bonds, let's quickly review what we know about electrons. We know that electrons are negatively charged particles, and we also know that electrons orbit around the nucleus. Okay? Now in these diagrams you see them orbiting around the nucleus in nice, neat, perfect little circles. We know that's not true. We know that they orbit around in clouds, and it's not quite as neat as these little circles. But for our purposes and for learning this, it makes it easier to draw them in nice, neat circles. Okay? Now, electrons orbit in these shells, and the first shell holds 2 electrons, like is shown here in the hydrogen atom. Hydrogen has 1 electron, but that shell that an electron orbits in will hold a maximum of 2. Okay? Then we go out in the second electron shell, and it can hold up to 8. And the rest of the electron shells can also hold up to 8. So that's why we have what's called the octet rule down here at the bottom. Atoms tend to gain or lose or share electrons so that they have 8 electrons in that outer shell. That makes them very stable. Okay? So everything when we talk about bonds here today, whether it be ionic or covalent, we're looking at atoms trying to gain or lose or share electrons so that they have 8 electrons, or that outer shell that they have is full. Okay? Electrons are important because elements have different electron configurations. Different electron configurations mean different types of bonding. And here we have an example of the periodic table of elements, and each of these columns in the periodic table represents how many electrons are in the outermost shell. So in this first column that has hydrogen, lithium, and sodium, they only have 1 electron in their outermost shell. And since they only have 1 in that outer shell, they tend to lose it. And that takes them back to that next shell, which has 8 in it, and it's full, and they're happy. Okay? But they also lose, when they lose that electron, they lose a negatively charged particle. So when you lose a negatively charged particle, you tend to become positive, and they do. Okay? So these elements over here, hydrogen, lithium, and sodium, tend to form ions because they lose an electron. By the same token here, beryllium and magnesium in this second column, they only have 2 electrons in their outermost shell, and that's not very stable either. So they tend to want to lose those outer 2 so that they're back to that next shell, which is full. They're happy. But when these guys lose 2 electrons, they lose 2 negative charges, so they become positive 2 ions. And that's true over here as well. Okay? We have boron and aluminum. They only have 3 in that outermost shell, and they tend to want to lose it. Now once we get past 3, then we start going the other direction. Instead of wanting to lose it, they tend to want to gain electrons to fill up that shell, as opposed to get rid of those lonely 1, 2, or 3 electrons out there. So the further we go to the right, the closer we get to having a full electron shell, and the more those elements want to gain an electron. And if you think about it, when they gain a negative electron, okay, then they're gaining a negative charge, so they become negatively charged ions. Because they're gaining an electron, they're gaining a negative charge. Ionic bonds are formed between two ions by the transfer of electrons. Okay? Those metals over on the left-hand side of the periodic table give up an electron, and those non-metals over on the right-hand side of the periodic table steal those electrons that were given up by the metals. So now we have a positively charged atom and a negatively charged atom. And if you've ever played with a magnet, you know positively charged items are drawn to negatively charged items. So an ionic bond is really the attraction between a positive atom and a negative atom. Okay? Because one stole an electron from the other. Some examples of ionic bonds would be NaCl, sodium chloride, and that would be the table salt that you and I put on our food. In this example, you can see that the sodium element, or the sodium atom, is giving its electron to the chlorine. Okay? So now it's stable, but it's also positively charged. The chlorine over here gains an electron to now have a full electron shell, so it's happy, but it's also negatively charged now, so we have an attraction between a positive and a negative. Remember, opposites attract. Okay? So an ionic bond is formed between two atoms. One gives up an electron and one steals it. Okay? Another way of thinking about it, these dogs are fighting over a bone. Okay? The big dog steals the bone, and the little dog is attracted to him because he wants that bone. Okay? So opposites attract. They're drawn to each other, an ionic bond. There's another diagram that shows it. The sodium ion gives up an electron, the chlorine accepts it, and in doing so they become positively charged and negatively charged, and they're drawn to each other. Covalent bonds, the other kind of chemical bonds, it's not done by stealing or giving up an electron. It is formed by sharing. Okay? Things to remember about covalent bonds is they form between non-metallic elements. Okay? So these are non-metals of similar electromagneticity. Okay? They share electron pairs. They don't steal, they don't give up one and one doesn't gain one. Okay? They simply share them. And examples would be like oxygen with itself to form O2. Carbon dioxide is also covalently bonded. Okay? And here's a diagram that shows it. Okay? One does not steal the electron from the other. They simply come together and share an electron. Actually, they share an electron pair. But again, it works to fill those outer shells in both of them. We have two kinds of covalent bonds. Now they're sharing either way, but a nonpolar covalent bond, the electrons are shared equally. Okay? Like these two oxygen atoms, the electron pair is shared equally. Now notice, when they share it, it gives them both those nice full outer layers there. It makes them very happy. And then we have polar covalent bonds. The electrons are still shared, just like in the other one, but this time the sharing's a little unequal. Okay? They're still sharing this bone, but the big dog's got it a little closer. Okay, and the example of water is a polar molecule because oxygen is stronger. It has a stronger attraction than the hydrogen, so it keeps the electrons closer to it than it does with the hydrogen. But they're still sharing, they're not stealing, so it is a covalent bond. Okay? If I could wrap this up and make it as simple as absolutely possible, if we're talking about electron or ionic bonds, we're talking about electron thieves. One atom gives up an electron, one takes it. All right, so there is an exchange there. It's a stealing. One takes, one gives it up. Covalent bonds, it's a sharing situation. They both share a pair of electrons. All right. I hope that helps, guys, and if you need additional help, don't hesitate to contact me. Thank you.